example. We're going to learn how to do a 128-bit addition. Did you know that you could do that? Do you need to? I mean, that's a really big number. But if you want to do scientific analysis and you want to process some really big numbers, like universal size numbers, I already thought that 64-bit would be big enough, but maybe it's not. Maybe we need 128. We're going to hang out. We're going to do some assembly today. We're going to learn chapter 2. We're going to walk through chapter 2. I'm actually kind of curious. There's different examples for doing addition. Simple numeric addition. We're going to do, or is it? It might not be simple. And in fact, I did a little bit of looking ahead, and there's an example too here. And it turns out you can do some really big number addition, including 128-bit. Look at these numbers. First 64. Look at these address, this hex numbers. Look at this hex number. It's huge. These are huge numbers. I mean, just having a 64-bit number, you thought that was plenty. I thought that was plenty enough. 64-bit would be more than enough. But it turns out, guess what? Thank you for the likes. Thank you for the like. Hey, guess what? You can do even more. Today, Ashford, we're going to be doing some assembly. We're doing some assembly today. We're going to do chapter 2. So we're here in this repository. It's called HelloSilicon, I think. Is it? Yep, HelloSilicon. So you can hear on the screen. So we've got HelloSilicon here. Today's lesson, teacher, we are learning together. We're going to learn together. We haven't done this. We haven't done addition before. Well, I mean, no, we haven't. We've only done comparisons. We've only done comparisons before. There we go. That's what we're going to do today. So we're going to be learning a little bit more assembly because I don't know assembly. I know of assembly, and I know a few things. Here's the start. So here's our entry point. We're immediately going to use register 0 or register W0. Now we know that there's an X0 and a W0, right? An X0 and W0. So this is the first register that we have access to. And I do believe that this is a 16-bit register, right? Or is it the 32-bit? But I know there's a 64-bit register maybe. I'm not sure. So let's see. W0 is a 32-bit register. Okay. And then X0 is a 64-bit register. So we don't need to use X0 because it's, really big register. We don't need a big register like it. We can use a 32-bit register because the number that we're going to be adding or manipulating here is the number 2. You can see number 2 on the screen. So essentially this says assign register 0 the value of 2. That's basically what it is. So like in Java or like JavaScript or another language, GCC compiles it down to assembly. Yes, that's the compilation step. That's the compile step, right? GCC will take your higher level code, Rust, Go, or it could be a C, right? C++, and it compiles it down to assembly. And then your assembly assembles your assemble opcodes into binary machine readable, and then your linker will come in and I think that's right. You assemble and then you link with the operating system. So it goes three steps. It's 3 steps, you guys. Okay. To assemble, then the assembler, which further converts it to machine language. You got it. Move in, which basically says this is like saying W0 equals 2 is what this statement says. W0 equals 2, and then the add is going to be what is this? What is actually? I'm not sure what I know what the add is. The add is going to be really simple. So this will be W0 equals W0 plus 1. That's what that means. So there we go. Okay, let's get back to learning some more things. Okay. So we learned here that add is going to be the same as W0 equals W0 plus 1. We know that we said W0 is equal to 2 right here. So W0 equals 2. So the answer should be 3, right? Basically, the answer should be 3. That's what's happening. So now W0 equals 3. Let's get back to it. So then we do move 16 and exit. Okay. So if we run this program, all it's going to do is actually modify the register, but it's not going to print anything out. This is just going to operate. It's just going to do the work and then close. So let's see if we can, let's get rid of that. Let's close everything here. All right. So let's run make. Okay. So now we've got move example 1. So let's do, add example 1. I think this is .s. Here we go. So here it is. Okay, so this is the program. Use a debugger. You can check registers there. You can. Wait, really? You guys, we did it. Okay, we were using the wrong debugger. You guys, you're supposed to chat. You're supposed to say, hey, Steven. Hey, Steven. You're using the wrong debugger. You need to use LLDB. Why are you using GDB? What's wrong with you? Well, hey, guess what? It's because I'm used to GDB, and I've known about GDB, and I use GDB a lot for many years, and I didn't know that LLDB was a different thing. I figured you were using GNU toolchain for a reason. Yeah, exactly. Can we print W0? Print W0. Can we do it? Unsigned integer. It's not 3, but you know what? It's a number. I'm perfectly happy with it. This is the moment. This is why you do software engineering, you guys. This is the moment. You struggle, it doesn't work. You try to get it to work, it doesn't work. We've succeeded. We got the debugger to work. We did it. Now we're off to back tomorrow with more assembly and more technology chat, and we'll figure things out.